Okay, here goes. Tangents and normals. So we are finding a tangent to the square root of 4x plus 1 at x equals 2 in the form ax plus by plus c is nothing. So we start off by writing y equals 4x plus 1 to the power a half. And of course we're differentiating that. Okay, so we put dy by dx is a half, 4x plus 1 to the minus a half, times by 4, which is 2 times 4x plus 1 to the minus a half. Now you are screwed if you don't differentiate properly. And that is the main thing that you really need to focus on. And you should know how to do tangents because it's C1. So now we've got the gradient at any point, but we want it not just at any point, but x equals 2. So we're basically doing 2 times 9 to the minus a half. Now 9 to the minus a half is 1/3 because 9 to the half is 3, so that will be 1 over it. So 2 times a third is 2/3. So the gradient at x is 2 on this curve is 2/3. Okay, so now we know that we have got x equals 2. We've got the gradient. Now we need the y coordinate. So if x is 2 and y is the square root of 4x plus 1, that's the square root of 9. So y is 3. So the point 2, 3, the gradient 2/3. So we use y minus y1 is x minus x1. Okay, so we do y minus 3 equals 2/3 x minus 2. So I get y minus 3 is 2/3 x minus 4/3. Now we want it in the format ax plus by plus c is nothing, where a, b and c are integers, preferably. So we're going to times right through by 3. Now make sure you times everything by 3 right through, like so. And let's get it all on the left hand side. So it's 3y minus 2x minus 5 is nothing. Okay, and let's check the point 2, 3 in there. That will go 9 minus 4 minus 5 is nothing, so we're all good. Okay, so that will be about 4 or 5 marks, guys, and it is just differentiate, find the coordinates, put it into y minus y1 is mx minus x1, and as long as you differentiate properly, I can't see anyone getting that wrong. Now let's get a bit more difficult. Find the normal to y equals 3 sine 2x plus 4 cos 2x at 0, 4. Now this is like a notoriously badly done question for some reason, and I don't really understand why, because I can do it easily. Bit of smugness there from me. So 3 sine 2x, some people get this confused with chain rule because it is, some people would put sine and a cos in the answer, but it seriously just goes to 6. So dy over dx, if we're differentiating, sorry, is 6 cos 2x, and we're differentiating cos 2x, so that will go to minus 8 sine 2x. So cos differentiates to minus, and that's what it goes to. So sine goes to cos, but times it by 2. Cos goes to minus sine, but again times it by 2. So that is our gradient at any point. Okay. Now we're using 0, 4. So we're going to work out the gradient at 0, 4, which is 6 cos nothing minus 8 sine nothing. Now 6 cos nothing minus 8 sine nothing, type into calculator and you get 6 times 1 minus nothing, so it's 6. Now we want a normal though, so we're going to go gradient minus 1 over that. So the normal gradient is minus 1/6. So write all that down, and then seriously all I do is I do y minus y1 again equals x minus x1. So y minus 4 is minus 1/6 x minus nothing, so like that. And then to make it look nicer, I'm going to times by 6, so you get 6y minus 24 is minus x. So 6y plus x minus 24 is nothing when you simplify it. And does 0, 4 work? 24 plus nothing minus 24 is nothing, so yeah, it's another good few marks there for us. I'll try to cover all angles with my videos, and this is one that intrigued me when I was looking through every differentiation question ever. Now, I know that although it's not difficult, people get this wrong because it's a bit of a curveball at the throw-in, if you pardon the pun. Now y equals ln x plus k, and it says a tangent to this curve at x is 3 is parallel to 9y is 2x plus 1, find k. Now I'm sorry, but if it mentions the word tangent, I would differentiate straight away, unless you're given the gradient. So if I've started with y equals ln of x plus k, then that is an awkward thing to differentiate. But if you differentiate a log function, it is a differential over the thing you're logging. So it's k over x plus k. Okay? Now we know that the tangent at x is 3 is parallel to 9y equals 2x plus 1. Now 9y equals 2x plus 1, I divide by 9 and I get the gradient, which is 2 nines. So if I've got the gradient 2 nines, I know that the gradient at x is 3 is equal to 2 nines. Now the gradient at x equals 3 is k over 3 plus k. Now if you don't understand that, it's because the gradient is always k over x plus k, but we want it x equals 3. So the gradient x equals 3 is k over 3 plus k, but we just found out it's 2 nines. Now I do a little bit of cross multiplication there, so you get 9k equals 6 plus 2k, 7k equals 6, so k is 6 sevenths. And that was a 4 marker that I reckon if you don't do the differentiation properly, because it's a bit of a dodgy differentiation, then you will mess up on that question. Now, last but not least, this is a tricky one, and it's like a double flip. That again is a bit of a curveball. So, find the normal to x equals 2 sine y at root 2 pi over 4 in the form y equals mx plus c, where m and c are exact. Okay. So what I'm going to do here is, first of all, because we're working with normals, I'm going to differentiate. So dx over dy is 2 cos y. And I'll get your mark. Okay. Now then I put 2 cos of pi over 4, because I'm working with a y function, and that will give me dx over dy at any point. Now 2 cos of pi over 4 equals 2 times root 2 over 2. If you type in the calculator, obviously we're in radians, and that gives me dx over dy is root 2. Now dy over dx, the gradient, which will be the tangent gradient, is 1 over root 2. But then now to get a normal gradient, and that's a double flip which confuses some people, I have to flip again, but negative. So minus root 2. So it goes to root 2, 1 over root 2, but then back to minus root 2. So we now use root 2 pi over 4. So we do y minus y1 is mx minus x1. And that gets me y minus pi over 4 is minus root 2 x minus root 2. So y minus the y coordinate is m, x minus x coordinate, and I get this. So you get y minus pi over 4, dodgy looking, equals minus root 2x, but plus 2 there. So minus root 2 times minus root 2 is 2. So we get y minus pi over 4 is minus root 2x plus 2. And then rearrange, y equals mx plus c. Y is minus root 2x plus 2 plus pi over 4. So m is minus root 2 and c is 2 plus pi over 4.